Hello everyone, this is Mr. B with some Algebra 2 notes, 3.5 systems of three equations. All right, we'll just jump straight into it. First thing, so systems of three equations. These are pretty much always going to have three variables in every equation. You will see here in a little bit later how you can have an equation or a system of equations with three variables, but not one variable represented in every equation, but we'll be able to solve those still, so don't worry about that at all. All right, so first, to solve a system of equations, to solve a system of three equations, use both inverse and substitution methods. So we'll go over both of those. A substitution, like we did with a system of two equations, can be very, very simple, especially if we have one equation that is very easy to kind of force into that format. But the inverse is usually what we go with just because it results in just kind of rounder numbers. There's honestly less math involved, so there's just less room to make a minor mistake. The solution to a system of three equations is called an ordered triple. And that is written as very much like ordered pair, just x, y, and then z. If you have another system of equations, say we're solving for a, b, and c, it's traditional to write those in alphabetical order. So a, comma, b, comma, c. Pretty straightforward stuff there. If it's not represented in letters that you can string together in that order, I would just write it out, x equals, y equals, and z equals, instead of trying to force it into an ordered triple. That won't make a lot of sense. So let's jump through a quick example. So step one, force the equation to negate one variable from all other equations. So this is just the inverse method, said in a little bit different way. The big thing that I look for when I'm trying to solve a system of three equations like this is two equations that already have the same coefficient in front of the same variable. What I mean is this positive 2 in front of the z. If we just mess with this one equation here in the middle, we should be able to get it to equal. Say it was something a little bit different. I would still, well, we'll jump through it. You'll see what I mean. So I'm going to take this middle equation and multiply the entire thing. Put the whole thing in brackets just to make sure we don't mix something up. And I'm going to multiply it by negative 2. That's going to give me negative 4x. Oh, I'm sorry, just positive 2. What am I thinking? Just positive 2. So it's going to give us 4x plus 2y minus 2z equals 5. Now I'm going to do the same step that we did with the other inverse method with just a system of two equations with both of the other equations here. So we'll have two equations with just x's and just y's. So we've already forced one. I'll write these into the steps here. So we have 4x plus 2y minus 2z equals, 10. What am I doing? This is not a 5 here, that's a 10. All right, so we've got that. Now combine the two inverse equations with or combine the inverse equation with the two remaining equations to negate that variable. All right, so there is just more writing involved, but again, I genuinely think that there is less math here. So we're going to write this one in. I'm just going to write this one in twice because we're going to add it to two different equations, remember. Minus 2z equals 10. And then same thing over here, 4x plus 2y minus 2z equals 10. Now I'm going to write in the other two equations that we have. This one's 5x plus 3y plus 2z equals 2. The other one we have is just x plus 4y plus 2z equals 16. All right, we'll add everything down. So we get 9x, move this up a little bit, it's easier for me to write, 9x plus 5y. There's no more z's to worry about. The negative 2 and the positive 2z will cancel each other out, so that just equals 12. Same thing with this one over here. We'll get, well, something slightly different, 5x plus 6y equals 26. At this point, I like to look at all the variables that we have. So we have a 9x and a 5x. Those aren't really close to each other. We have a 5y and a 6y. While the coefficients 6 and 5 are close to each other, they're not very close as far as sharing a common factor or something like that. So there's not really a correct way to approach this problem going forward other than just forcing the coefficients of either x or y to be the inverse of the other. I'm going to pick the y here just because we'll have to multiply this side by a 6, and we'll have to multiply this side by a 5 or a -5. One of those will have to be negative. The reason I know it's going to be 6 and 5 is because we have a 6 over here. We have a 5 over here. You just kind of want to do the opposite operation. This is almost like a finding an inverse or something like that. So yeah, we'll jump straight into it because they don't share any common factors. That's the smallest we can get it. But 5 times 6 is 30. 6 times 5 is 30. That's why we're going to pick those two numbers. So I'm going to repeat step 1 here for both of the equations. We'll have to mess with both of them. So remember, I'm multiplying this equation by 6 and this whole equation by 5. The numbers will get large, but I genuinely do believe that this is the easier way to go than trying to substitute everything in. All right, so let's see. 6 times 9 is going to be 54x, not 5x, 54x plus 30y. So I'm actually going to multiply this side over here by -5. Multiply by -5. That way they'll be the inverse of each other. 6 times 12 is going to be 72. And then this side over here will have -25x minus 30y. So then these two will cancel each other out. That's why we're doing this. Equals, let's see, I'm going to use my calculator for this one. All right, that will give us -130. Now we just add these together. So let's see, I'm going to take a -25x, the -30y equals -130. Let's see, 54 plus -25x is going to be 29x, and that's going to be 0y. And then 72 minus 130 is -58. -58. If we take that and divide it by 29, we'll get x equals -2. Easy enough. Now we can take this value and just kind of work our way backwards. I'm going to plug it in to either of these equations. It doesn't matter which one. So I'm going to take x and plug it into this right-hand equation. So we will get 5 times -2. Oh, let me actually follow my steps here. We'll plug that in. 5 times -2. If I hit the right tool here. Okay, there we go. 5 times -2 plus, I believe, plus 6y equals 26. Okay, so that's -10 plus 6y equals 26. We'll add 10 to each side. So that gives us 6y equals 36. And that gives us y equals 6 after we divide by 6. So now we've got two variables. And now we can use those last two, this x equals -2 and the y equals 6, to plug it into any of our original equations. That'll give us the value for z. I'm going to use this middle one here just because it's a little simpler. Why not? So we have 2x plus y minus z. Let me actually zoom out, and then I'll be able to see it. Right. 2x plus y minus z equals 5. Okay, let me zoom in again. And we know that x equals -2, so 2 times -2 is -4, plus y, which is 6, minus z equals 5. -4 plus 6 is -2, minus z equals 5. So I'll add 2 to each side. We get -z equals 7. So that means z equals -7. Now to write this as an ordered triple, remember that's kind of the where we want to get to with a lot of these. So x is negative 2, y is 6, z is negative 7. That's what we're looking for. Let's do one more here. Well, two more it looks like. Okay. This first one here looks a little bit different. It's set up in a way that's not quite clear. So I'm going to write this over here. P, Q, R is the alphabetical order that we want these in. I'm going to rewrite these equations and line up the unseen variables. That's what I'm talking about right here. So let me take a stab at that. I'm going to say this is P plus a 0Q. There's no Q's there, so I'm just going to skip that and kind of leave a space for R. And I'm actually going to put the plus over here so we know that it's a positive for R. The next one here, we have the P. So P minus 3Q, we have that minus 3Q, but we're missing the R. So I'm just going to leave that blank. Oh, and of course, right in the negative 7 over here and the negative 8 over here as well. For this next one, I'm going to write in the Q but skip the P. Plus R equals 1. That's everything. Now, I need these coefficients, one of these coefficients, to equal the inverse of all others, or to eliminate them from the other equations. This can be kind of tricky when you're first looking at it, but once you kind of just take an individual piece of it, you'll realize that it's not actually going to be too hard. So I am going to basically leave this equation alone. I'm not going to touch it. I'm just going to try and get the Q or the R out of this one. Well, actually, it has to be the Q. I apologize. I'm going to just get the Q away from these two so that we can have one final equation with just P's and R's in it, and then we'll treat it like a system of two equations. You can do the same thing with P's. You can do the same thing with R's. Does not matter. I just like that this one is already positive and this one is already negative, so I don't need to deal with multiplying by negatives. That's usually where I mess up. If you find a method that works better for you, though, by all means, jump through that. So I'm going to multiply this equation by 3. So I will get, let's see, 3Q plus 3R equals 3. And then I'll add these equations together. So I'll add the P minus 3Q and then 0R equals the negative 8. And I'm just going to add these together. So I'll be left with a P, but no Q. And then 3R plus 3R equals negative 5. And now, all of a sudden, I've got two more equations. I've got also P plus 4R equals negative 7. So we can treat this a couple different ways. There's several methods for solving these systems of equations. I am going to, let's see, what should I do for this one? I'm just going to multiply one by a negative. Add them together, get rid of the p's, and then we'll take it from there. It'll be pretty quick and easy that way. I'm going to multiply this left one by a negative 1, so that would be negative p minus 3r equals positive 5. That's by multiplying, again, by negative 1. And then I'll add them together. The p plus 4r equals negative 7. When we add everything down, we'll get no p's, 1r equals negative 2. That's our first solution. Now we can plug everything else in. I'm going to plug it into this first equation, or this last equation, I'm sorry, that we have, just because the math is going to be easy. So Q minus 2 equals 1. We'll add 2 to each side. So that means Q equals 3. And now we can plug any either Q or R into these top two equations. Totally up to you. I'll plug it into the top one just because there's more positive numbers up there, I guess. Not really any real reason. I'm going to square that, though, so I can find it later. We have P plus 4 times negative 2 equals negative 7. So that means P minus 8 equals negative 7. If we add 8 to each side, we get P equals 1. And remember, we want to write this as an ordered triple if we can, and we can. These are all alphabetical letters here. They all represent they're right next to each other in the alphabet. So we'll write that as an ordered triple. PQR 1, 3, -2. That's everything. On to the next one here. We've got a word problem for you guys. Let's see. A fundraiser raised $48,000 for children in a low-income suburb. The foundation is purchasing. Oh, hit the wrong button there. There we go. The foundation is purchasing X-Trek backpacks for $20, Yancey sweaters for $25, and Zeal-bound books for $5. They want to buy 400 items total. They will buy the same number of sweaters and backpacks. Okay, so we can get 3 different equations from this. It might seem kind of tough at the outset, but we absolutely can. I'm going to use X for X-Trek backpacks, Y for Yancey sweaters, and Z for Zeal-bound books. So let's see. The foundation is purchasing X-Trek, so 20X, $1 for every backpack, or $20 for every backpack, plus 25Y plus 5Z equals 48,000. Now, a trick with a lot of these is the first formula, the first equation that you come up with does not need to be the one that you run with the entire time. A quick glance at this can tell me that all of these numbers are divisible by 5. So I'm going to divide the entire equation by 5. There's nothing stopping me here, and that'll just make all of our math going forward a little bit easier. We're going to have to do this step later to get down to an equation anyway, so we might as well tackle it now. 48,000 divided by 5 is 960. 960. 5 divided by 5 is just 1, so that would just be z. That'd be 5y and 4x. These are similar equations. They're not the same equation. Never say that they're the same, but they are similar, meaning that they're just scaled up or down, and they're meaning the same things. These would graph the same plane if we graphed it in 3-dimensional space with x's, y's, and z's. So I'm going to just kind of lightly, oops, didn't mean to erase that, just kind of lightly cross this out so I don't accidentally use that in the future, because what we have now is just a more condensed version of that info. The next piece is that they'll want to buy 400 items total. Okay, so that's just x plus y plus, oh, I should line these up, z equals 400. Let me erase this and write it in line. That's something that I'm still trying to get into the habit of. And they'll buy the same number of sweaters and backpacks. Okay, that's y and x. So y and x equal each other. Y equals x. I'm going to rewrite this as I'm going to subtract y from each side. So I get x minus y equals 0. And if you wrote this negative x plus y equals 0, actually the same equation. They look very different. Either of these will work. And I wrote them x first, y second, so that it lines up. I'm going to use my first one, though. X minus y equals 0. All right. Now just a few more steps. I'm going to take both of these equations. Well, actually, I was going to say multiply them both by 5 so that this resultant equation would eliminate y's from everything, but we already have one equation without any z's. So why don't we get rid of one of the z's? That's going to be actually pretty easy for us just by multiplying one of these by -1. So I'm going to do that. I'm going to multiply this one by -1, and that will give me negative x minus y minus z equals -400. And then I'm going to add the other equation with z, so I'll have 2 equations without z. Let's see, so I'll add 4x, and I'll add 5y, and I'll add the z, those will cancel out, and I'll add 960. What we get left is 3x plus 4y equals, let's see, that minus 400 would be 560. Now the 2 equations that we have left look pretty basic. X minus y equals 0. I'm going to multiply this bottom equation by 3, so that when we add them together, by 4, so that the y's cancel out. I could have multiplied it by a -3 as well to get rid of the x's, but like I said, I don't really like multiplying by negatives. It's easy for me to mess up. So I'm going to get, let's see, I'll write this over on the right-hand side. So this work is coming over. I'll just rewrite the top equation, 3x plus 4y equals 560. So we get 4x minus 4y equals 0. 0 times 4 is still 0. So the y's will cancel out, but we'll be left with 7x equals 560. Now if we divide that 560 by 7, we should get to 80. So x equals 80. Now I'm going to take a quick step back, and remember, we had an equation that's going to make this very easy. Y equals x. That means y equals 80 as well. We have 2 of the 3 numbers. We just need to figure out z. I'm going to plug it into this middle one. So we have 80 plus z equals 400. So 80 plus 80 plus z equals 400. That means 160 plus z equals 400. And that means that z equals, let me just double check my math here. It's been a long day and I don't want to get it wrong. I believe 240. 400 minus 160. Yep, 240. 240. And we can write this as an ordered pair. X, Y, Z is the easiest one, I think, to do. So we would get 80, 80, 240. If you have any questions on how we jump through this, I know it can be kind of intimidating, but remember, we're just looking to eliminate one variable here. As long as you keep that step in mind, I think these are honestly pretty easy. They can be a lot of work. There's a lot of arithmetic going on, but if you plan ahead, especially with this something like that little trick of converting this down, your work is going to be pretty easy. I genuinely think that. So if you have any questions, please reach out to me in class. I'll be here for the next week. Well, by the time you guys are seeing this video, I guess it'll be too late, but Miss Kavanaugh will be there to answer any questions that you have, and I'm still planning on being back in the building once my time at Lewis Palmer Middle is up. That's 2 weeks. All right. I hope to see you guys in the future, and if not, it was a pleasure teaching you guys. I wish you all the best, and I know you all can do it. We'll see you there.